Download this code from codegive.com, link in the description below. COM Hijacking for Persistence, a comprehensive tutorial. COM, Component Object Model, hijacking is a potent technique used to achieve persistence on Windows systems. It allows an attacker to gain code execution upon system startup or user interaction by replacing or redirecting COM object instantiations to their own malicious code. This tutorial provides a detailed explanation of COM hijacking, including its underlying mechanics, various hijacking methods, detection strategies, and mitigations, along with code examples to illustrate the concepts. Understanding COM, Component Object Model. Before diving into the hijacking techniques, it's essential to grasp the fundamentals of COM. *COM's purpose. *COM is a Microsoft technology enabling software components to interact with each other across different programming languages and processes. Think of it as a blueprint for creating reusable software modules. *Key concepts. Component. A self-contained, reusable piece of software. It exposes a set of interfaces. Interface. A collection of related functions, methods, that define a specific functionality. Components interact with each other through interfaces. CLSID, Class Identifier. A 128-bit globally unique identifier, GUID, that uniquely identifies a COM class, a template for creating COM objects. It's like the ID card for a specific type of component. Prog ID, Programmatic Identifier. A human-readable string that maps to a CLSID. Easier to use than CLSIDs, but less reliable. COM object. An instance of a COM class. It's the actual running component. Registry. The central database where COM configuration information is stored, including CLSIDs, Prog IDs, and their corresponding component paths. This is where the hijacking magic happens. DLL surrogate. If a COM object is configured to run in its own process, out of process COM server, the system spawns a DLL surrogate process, usually dlhost.exe, to host the component. This allows the component to run independently of the caller. COM activation. When an application wants to use a COM object, it doesn't directly load the DLL. Instead, it uses the COM API functions, like co-create_instance, to create an instance of the object. Here's the general flow. 1. Application requests an object. The application specifies the CLSID or Prog ID of the desired COM object. 2. COM runtime lookup. The COM runtime, part of Windows, looks up the CLSID/Prog ID in the registry. 3. Registry resolution. The registry contains information about how to create the object, including the path to the DLL containing the COM component. The threading model, example apartment, free, both. Whether the object should run in process or out of process. 4. Component loading, in process. If the object is in process, the DLL is loaded into the application's process. 5. Component activation. The COM runtime calls the appropriate function, typically DLL get class object and create instance, in the DLL to create the COM object. 6. Out of process activation, DLL surrogate. If the object is out of process, dlhost.exe, the DLL surrogate, is started. The DLL containing the COM component is loaded into dlhost.exe, and the object is created within that process. 7. Object returned. The application receives a pointer to the created COM object, allowing it to call the object's methods through its interfaces. 2. COM hijacking techniques. COM hijacking exploits the COM activation process by manipulating the registry to point to malicious code instead of the legitimate component. Here are some common techniques. 1. CLSID hijacking, most common. Target *. This is the most straightforward and widely used method. It targets specific CLSIDs. Mechanism *. The attacker modifies the registry entries associated with a CLSID. They typically change the in-proc server 32 or local server 32 value to point to a malicious DLL or executable. Scenario An application or service tries to create an instance of a specific COM object, identified by its CLSID. The COM runtime reads the registry entry for that CLSID. Instead of finding the legitimate DLL/exe, it finds the path to the attacker's malicious DLL/exe. The malicious code is loaded and executed. 2. Prog ID hijacking Target The attacker targets a prog ID. Mechanism The attacker modifies the registry entry associated with a prog ID to point to their own CLSID. When an application tries to create an object using the hijacked prog ID, it will instead create an instance of the attacker's malicious COM class. Vulnerability less reliable than CLSID hijacking because some applications may use CLSIDs directly, bypassing the prog ID lookup. 3. Treat as hijacking Target This technique manipulates the treat as registry key. Mechanism The treat as key allows one CLSID to be treated as if it were another. An attacker can set treat as for a legitimate CLSID to point to their own malicious CLSID. Effect Whenever an application tries to create the original legitimate object, it will instead create the attacker's malicious object. 4. App paths hijacking Target This method is slightly different. It hijacks the execution of a legitimate COM server, usually dlhost.exe or another executable. Mechanism The attacker places a malicious DLL in the same directory as the COM server executable, example dlhost.exe. Because the current directory is searched first when loading DLLs, the attacker's DLL, which often exports the same functions as the system DLLs, will be loaded instead of the intended system DLL. This is a classic DLL hijacking scenario. If the COM server then creates a COM object by loading a legitimate DLL, the attacker's DLL could be loaded first. Benefit This can bypass some security measures because it doesn't directly modify COM-related registry keys. 5. Elevation moniker hijacking Target This technique exploits COM elevation monikers, which are used to create COM objects with elevated privileges. Mechanism The attacker hijacks the CLSID associated with the elevated COM object. When an application attempts to create the elevated object, often used to perform privileged operations, it instead creates the attacker's malicious object with those privileges. 6. IFEO, Image File Execution Options, hijacking with DLL surrogate Target This method is similar to app paths, but uses IFEO. Mechanism Using IFEO, one can configure a debugger for an application, dlhost.exe. This debugger can be any executable. The attacker sets a malicious application/script as a debugger for dlhost.exe. Whenever the COM object is instantiated in a surrogate process, the debugger, attacker-controlled, is executed. 3. Code examples. Let's illustrate CLSID hijacking with a C++ code example. This example demonstrates how to change the inproc server 32 value for a specific CLS ID to point to a malicious DLL. Disclaimer ****. This code is for educational purposes only. Use it responsibly and only in environments where you have explicit permission to do so. Misuse of this code could have severe consequences. Explanation ****. 1. Headers * includes necessary Windows API headers. 2. Set registry string value function ***, a helper function to set a string value in the registry. Handles key creation and error checking. 3. Main function ***. CLS ID and DLL path * sets the CLS ID to hijack and the path to the malicious DLL. Crucially, you must replace the placeholder CLS ID and DLL path with valid values on the target system. Constructing the key path * creates the registry subkey path based on the CLS ID. Modifying inproc server 32 * calls the set registry string value function to modify the inproc server 32 value under the CLS ID key, pointing it to the malicious DLL. This is the core of the hijacking process. Error handling * checks for errors during registry operations and displays appropriate messages. Important note * the code targets HKey_current_user. This means the hijack will only affect the current user. To perform a system-wide hijack, you would use HKey_local_machine. Modifying HKey_local_machine requires administrator privileges. Cache flushing * the comments emphasize the need to flush the COM cache for the changes to take effect. This is often necessary after modifying COM registry settings. Malicious DLL, example, C++. This is a simplified example of a malicious DLL. The purpose is to demonstrate code execution, not to provide sophisticated malicious functionality. Explanation ***. DLL main * the entry point of the DLL. The DLL_process_attach case is executed when the DLL is loaded into a process. Malicious payload * the code within the DLL_process_attach block represents the malicious payload. In this example, it displays a message box and then launches CALCEXE. Replace this with your actual malicious code. Be aware that actions performed by the DLL will be executed in the context of the process that loads the DLL, which could have significant consequences if the DLL is loaded by a system process. DLL get class object and DLL can unload now. These functions are required exports for COM DLLs. For a simple hijack, they can be stubbed out. DLL get class object is responsible for creating class factories for COM objects, but since we are just hijacking the DLL load and not implementing a full COM object, we return E_fail. DLL can unload now determines whether the DLL can be unloaded, and returning S_false prevents it. Steps to perform the hijack *. 1. Identify a target CLS ID *. Use tools like olview.exe, included in the Windows SDK, or Process Monitor to find a suitable CLS ID that is frequently used on the target system. Look for CLS IDs whose inproc server 32 value is easily modifiable, example under HKey_current_user. Also, consider the privileges of the process that loads the COM object associated with that CLS ID. Hijacking a CLS ID used by a high-privilege process is more valuable for persistence. To develop the malicious DLL *, create your malicious DLL, following the example above, but replacing the placeholder code with your actual payload. Compile the DLL. Make sure the architecture, x86 or x64, matches the target process. 3. Modify the registry * run the C++ code from above, the hijacker program, providing the correct CLS ID and the path to your malicious DLL. Ensure you run the hijacker program with the appropriate privileges, administrator privileges for HKey_local_machine modifications. 4. Trigger the COM object creation * start the application or service that uses the hijacked COM object. This will trigger the loading of your malicious DLL. 5. Flush the COM cache * if the hijack doesn't work immediately, flush the COM cache as mentioned in the code comments. Important considerations for successful hijacking * privileges * modifying registry keys under HKey_local_machine requires administrator privileges. Hijacking a COM object used by a system service typically requires administrator privileges to modify the registry and to trigger the object creation. Architecture * ensure the architecture of your malicious DLL, x86 or x64, matches the architecture of the process that will load it. Mixing architectures will result in failure. Registry permissions * the user account running the hijacker program must have write access to the registry keys being modified. Target selection * choosing the right CLS ID is crucial. Find one that is frequently used, has the desired privileges, and is easily modifiable. COM cache * remember to flush the COM cache after making registry changes to ensure they take effect. Antivirus * antivirus software may detect and block COM hijacking attempts. Consider techniques to evade antivirus detection, such as obfuscating your malicious code. Digital signatures * some applications might verify the digital signature of the DLL being loaded. If this is the case, you won't be able to hijack it with an unsigned DLL. /APPLocker/WDAC * application control solutions like APPLocker or Windows Defender Application Control, WDAC, can prevent the execution of unauthorized code, including malicious DLLs used in COM hijacking. 4. Detection and mitigation. Detecting and mitigating COM hijacking is essential for maintaining system security. Detection techniques * 1. Registry monitoring * real-time monitoring * use tools like Sysmon or a custom monitoring solution to detect modifications to COM-related registry keys, example CLS ID, proc ID, treat as, in proc server 32, local server 32. Sysmon event IDs 12, 13, and 14 are particularly relevant. Periodic scanning * regularly scan the registry for suspicious or unexpected values in COM-related keys. Compare the current configuration to a known good baseline. 2. File system monitoring * DLL placement * monitor for the creation of new DLLs in system directories or application directories, especially if those DLLs are not digitally signed or have unexpected properties. DLL loading * tools like Process Monitor can show which DLLs are being loaded by which processes. Look for unexpected DLL loads, especially if the DLLs are unsigned or from untrusted locations. 3. Process monitoring * DLL surrogate behavior * monitor the behavior of dlhost.exe, the DLL surrogate process. Look for unusual child processes spawned by dlhost.exe or network connections originating from dlhost.exe. Process trees * examine process trees to identify suspicious parent-child relationships. For example, if a seemingly benign application spawns command.exe or PowerShell.exe, it could indicate malicious activity. 4. Event log analysis *. Asterisk system events asterisk analyze system event logs for errors related to COM object creation or DLL loading. Asterisk application events asterisk examine application event logs for errors related to specific COM objects. 5. Behavioral analysis asterisk. Asterisk endpoint detection and response, EDR, systems asterisk EDR solutions can analyze the behavior of processes and detect suspicious activities related to COM hijacking, such as unexpected registry modifications, DLL loading, or code execution. Asterisk sandbox analysis asterisk run suspicious files or processes in a sandbox environment to observe their behavior and identify potential COM hijacking attempts. Example Sysmon configuration, for detecting in proc server 32 changes. B. Mitigation strategies asterisk. 1. Principle of least privilege asterisk. Asterisk user accounts asterisk grant users only the minimum privileges necessary to perform their tasks. Avoid giving users administrator privileges unless absolutely required. Asterisk service accounts asterisk run services with dedicated service accounts that have limited privileges. Asterisk registry permissions asterisk restrict write access to COM-related registry keys to authorized users and groups. 2. Application control asterisk. Asterisk APPL occur asterisk use APPL occur to define rules that restrict which applications and DLLs can be executed on the system. Asterisk Windows Defender application control, WDAC WDAC provides a more robust application control mechanism than APPL occur. It can be configured to block the execution of unsigned or untrusted code. 3. Code signing asterisk. Asterisk digital signatures asterisk require all DLLs and executables to be digitally signed by a trusted certificate authority. This helps to ensure that the code has not been tampered with. Asterisk signature verification asterisk configure applications and services to verify the digital signatures of DLLs before loading them. 4. Patching and updates asterisk. Asterisk regular updates asterisk install the latest security patches and updates for Windows and all installed applications. These updates often address vulnerabilities that can be exploited for COM hijacking. 5. Registry hardening asterisk. Asterisk secure registry permissions asterisk set appropriate permissions on COM-related registry keys to prevent unauthorized modifications. Asterisk disable legacy COM features asterisk disable or remove legacy COM features that are no longer needed. 6. Anti-exploit technology asterisk. Asterisk Windows Defender Exploit Guard asterisk Exploit Guard includes features like attack surface reduction, ASR, and controlled folder access, which can help to prevent COM hijacking attacks. Asterisk third-party anti-exploit tools asterisk consider using third-party anti-exploit tools that provide additional protection against COM hijacking and other exploitation techniques. 7. Monitoring and alerting asterisk. Asterisk real-time monitoring asterisk implement real-time monitoring of COM-related registry keys, file system activity, and process behavior. Asterisk alerting asterisk configure alerts to notify security personnel of any suspicious activity that could indicate a COM hijacking attempt. 8. User education asterisk. Asterisk awareness training asterisk educate users about the risks of COM hijacking and other security threats. Asterisk phishing awareness asterisk train users to recognize and avoid phishing emails and other social engineering attacks that could lead to malware infections and COM hijacking. See remediation asterisk. If a COM hijacking attack is detected, 1. Isolate the affected system asterisk disconnect the affected system from the network to prevent further spread of the attack. 2. Identify the malicious code asterisk locate the malicious DLL or executable that was used in the hijacking attempt. 3. Remove the malicious code asterisk delete the malicious DLL or executable from the system. 4. Restore the registry *. Restore the COM-related registry keys to their original, legitimate values. This can be done manually or by using a system restore point or backup. 5. Scan for malware *. Perform a full system scan with a reputable antivirus or anti-malware solution to detect and remove any other malware that may be present. 6. Investigate the incident *. Investigate the incident to determine how the hijacking occurred and identify any vulnerabilities that need to be addressed. 7. Implement mitigation strategies *. Implement the mitigation strategies described above to prevent future COM hijacking attacks. 8. Forensic analysis *. Perform a thorough forensic analysis to understand the full extent of the compromise and identify any compromised data or systems. Conclusion. COM hijacking is a powerful persistence technique that can be used to gain persistent code execution on Windows systems. By understanding the underlying mechanisms of COM, the various hijacking methods, and the detection and mitigation strategies, security professionals can effectively protect their systems from this threat. Remember to always test these techniques in a safe and controlled environment, and to use the information responsibly. It's a cat and mouse game, and attackers are constantly evolving their tactics. Continuous monitoring, proactive hardening, and up-to-date security practices are essential for staying ahead of the curve.